So we talked about urea. We talked about a 5% dextrose. We also talked about a 0.9% saline. And then we talked about a mix of these two. So 5% dextrose and a 9% saline, or 0.9% saline. So let's start with urea. So most particles, or so these two, urea and dextrose, they can go inside of the cell. And so they can go inside the cell, no problem. And they're going to want to have equilibrium. So let's say these dots right here are urea. Let's say we have 4. So it's going to want to reach equilibrium. And so 2 would go into the cell, trying to reach the equilibrium. So with urea, if a solution has urea in it, then that urea is going to, even if it's an iso, let's say we have a 300 milliosmoles solution of this, and we put it in a 300 milliosmol solution, or sorry, if the cell is 300 milliosmol, even though it's isosmotic compared to each other, um, the effect would still be a hypotonic effect because urea wants to go inside of the cell, and when something goes inside of the cell, um, there's more particles there eventually, and so water is going to go to where the more particles are. The same thing could happen with dextrose, but dextrose is different in the fact that right when dextrose gets into the cell, it's going to metabolize, and so it kind of disappears. So if we have a cell with, and let's say these are dextrose, and this is isosmotic, these two compared to each other, dextrose is going to go into the cell, causing water to go in, but it's going to get metabolized immediately. And but more particles are still here on the inside, which means that water is still going to rush into the cell. Um, if we were to have a saline solution, then not much would happen because so these are 300. These are kind of standard, both of these. So if we put a saline solution, which again doesn't go into the cell, but it's 300, a 300 solution, this would just be like the example up here. So not much would happen. It would be an isotonic. However, if we mix the two, so let's draw this out. If we have a mix of the two, if we have a cell, it's got 300 on the inside, 300 milliosmoles, and let's say it has 300 of dextrose and 300 of that saline, 300 milliosmoles. So the saline would stay out, but the dextrose would go into the cell. So, well, okay, initially there's more particles on the outside as we see. So water would rush out of the cell, but dextrose is going to go in eventually, but then it gets metabolized. And so all of those dextrose reach equilibrium and then they go back and more go in and then it gets metabolized and then more go in, it gets metabolized. And so all of those are essentially going to disappear. And so we're left with, and so water would go back out of the cell to reach that equilibrium. Um, and so we would be left with this equilibrium on the outside, 300 on the outside and then 300 on the inside. Let me check if I covered everything. Um, so again, things can be isoosmotic, like that second example we used, or with the urea, or that first example with the urea, where it goes into the cell, um, and so initially it's isoosmotic, but the effect would be a hypotonic effect, like we talked about. Um, and yeah, I believe that is it.